So we've got a beam, simply supported, 68 kilonewtons per metre. You're given the type of beam and you're asked to calculate the maximum deflection, given that the A value, so it's a steel, is 205 kilonewtons per millimetre squared. Usually when you're given the beam itself, you're going to have to try and sort of pull off some tables from our, pull off some values from our table. We can immediately sort of look again at our deflection formula. So we got our D max this is what we're trying to find out, the maximum deflection. 5 over 384 WL cubed over EI. We can work out what our total load is. We've got the span, we've been given E. This has been given so that we can try and find out the I. So find I from tables. So again, if you looked at the back of your handout, we would find so it's a 406 by 178 by 54. So find the beam. We've got mass per metre, depth, width, thickness of the web, go all the way along until we reach our second moment of area. And, you know, our load has been applied at the top. So we need to be looking at the second moment of area in the XX axis. So you've got 18720 centimetres to the 4. IXX 187.2 times 10 to the 2 centimetres to the 4. So this D max is 5 over 384 multiplied by our W. Again, remember that our W is the UDL times by L. So if we were going to put in for the W here, we got 68 times by 5. And then we got times by 5 cubed over E. So we got 205 times by our I, 187.2. Now, our problem is that we have to make sure that everything is in kilonewtons, newtons, millimetres, metres. So let's have a look at that. Let's put everything into metres and, newtons and millimetres. So we've got, this would be 68, so I'll rewrite this out. So 5 over 384 times by, so we've got 68,000 newtons times by 5,000 millimetres times by 5,000 millimetres cubed. We've got 205 kilonewtons per millimetre squared. So if we 205 times 10 to the 3, and then times by our I value, which is in centimetres to the 4. Don't you just wish that all of the values just came in millimetres and newtons? You'll find that most tables have their I value in centimetres, but it's just to make the calcs fun for you. 187 times 10 to the 2 centimetres to the 4 is the same as 187 times 10 to the 6 millimetres to the 4. .4 millimetres is what you should come to with your calculator. That there is the actual deflection. You can compare this to the allowable deflection, and like it would say sort of within the question itself, it would say that the allowable deflection is 1 in 360. So if we did span over 360, so it's 5 metres divided by 360. The allowable is 13.9 millimetres. So therefore, it's failed. You'd have to choose another beam with a deeper, like a larger I value, or choose another material. Normally you wouldn't be choosing another material. You would have to add something to increase the I value. What you could do, you could put the allowable deflection, this 13.9, you could put that into the equation, 13.9 there, and you could leave out your I value, and you could find out a value of I. Then afterwards, once you've got your value of I, you can go down your I values and try and find a beam that has got a larger I value than what you've worked out, and then you can choose a beam. So you've got to, you probably have to have a 406,178 times by 60 beam.